So once again, welcome to all. So today we are going to have the second part of the topic air pollution in IC engines and remedies. So already in part 1 we have discussed what are the major exhaust emissions and their cause. Now we will be focusing on these remedies. What are the possible remedies for reducing these emissions? So the main objectives of this class is to discuss the following emission control methods. First we will discuss thermal converters, then catalytic converters and their working. What is particulate traps, how to use particulate traps. Then we will discuss the chemical methods for reducing emission. And finally, we will have exhaust gas recirculation, which is known as EGR. Now, what is thermal converter? As the name suggests, it depends on temperature. So, you know that carbon monoxide and hydrocarbon emission is the two major emissions coming from an engine. And if we have excess of oxygen in the exhaust, this carbon monoxide can be again converted into carbon dioxide. So thermal converters are a high temperature chamber which the exhaust gas flows. So it is a high temperature chamber. And what they do is they promote the secondary oxidation reactions of carbon monoxide and hydrocarbons. So already the first oxidation, after the first primary oxidation, the carbon is converted to carbon monoxide and hydrocarbons are formed. So it will do the secondary oxidation. What is secondary oxidation? Yes, the oxygen, the excess oxygen present in the exhaust will react with this carbon monoxide to convert it to carbon dioxide. So carbon monoxide is converted to carbon dioxide. And you can see here the temperature required for this reaction is 700 degrees Celsius. Similarly, the hydrocarbons, any hydrocarbon will react with oxygen to form carbon dioxide and again water vapor. But this reaction also, the temperature required is 600 degrees Celsius and it should maintain that at 50 milliseconds of time. So this time is also important. The temperature should be maintained for at least this much time. So a thermal converter therefore should operate this temperature range, that is the temperature of this chamber must be around 700 degree and also it should provide adequate residence time. So what is residence time is the time that the gas will be present inside that chamber is known as the residence time. So here you can see the 50 milliseconds you have to maintain the gas at this temperature. So that means the residence time is 50 milliseconds at least. So the thermal converter will do this temperature, provide this high temperature for that much time. And where they are connected, generally to minimize the heat loss, they will be connected immediately outside the exhaust port. So after the exhaust valve itself in the exhaust manifold, this chamber can be connected. And some thermal converters also take air from outside. So we know that we require oxygen for all this reaction. And therefore some thermal converter take air from the outside atmosphere, but it will increase the size and complexity of this thermal converter. Then what are the limitations? Have you any idea what are the limitations of these thermal converters? Yes, the first one is, you know that the modern automobile engine will be very small and it will not have a large space for accommodating this thermal converter because it is a lengthy chamber. So we may not be able to accommodate this in every engine compartment. So that is the first limitation. The size of this will be a problem. And another one is the heat loss. Even though the thermal converters are insulated, this temperature is very high, 700 degrees. So some heat will be lost and they will cause some problem in the engine compartment. that is another limitation. The heat loss from this chamber will have some problem in the engine compartment. And another thing is, you know that NOx emission, another important emission we have to reduce from IC engine, but this chamber does not do anything with the NOx emission. So it cannot be reduced using this thermal converter. So these are the main limitations of this thermal converter. So second thing, we have the catalytic converter. So this will somehow eliminate the disadvantages of thermal converters. So most of the modern vehicles, so this is a figure of catalytic converter. This is a small chamber with this shape. This can be connected the exhaust manifold. So gas will be passing through this and will lead to the exhaust tailpipe through this side. So what is a catalytic converter? Most of the modern vehicles use this as an effective after treatment method. So this is all this method, thermal converter and catalytic converter, we are treating the gas after the production in the engine. So it is an after treatment method that is used in most of the automobiles and modern engines. So what is a catalyst? So you know what is a catalyst is. Already you have studied in your chemistry. Just recollect that. What is a catalyst? Yes, a catalyst is a substance that accelerate a chemical reaction by lowering the activation energy for that reaction. So it will be any substance that will increase the rate of speed of that reaction by lowering the energy required for that reaction. And the most important thing is they will not be consumed in that reaction. So that means the catalyst will not take part in the reaction. They will remain as such and we can use it indefinitely. That is the important advantage of catalyst. We can use it indefinitely unless it is degraded by some heat or age or other contaminants. So that is the advantage of catalytic converter. Once that catalyst we are used, we can use it for several kilometers once it is degraded by age or some other problem. Now what is a catalytic converter? It is a steel chamber, stainless steel container of this shape mounted in the exhaust pipe of the engine. So it's made of, the outer chamber is made of stainless steel. And inside this chamber, if you look deeper into this catalytic converter, you can see a honeycomb structure of ceramic material with a large number of flow passages. So this is a small cross section you can see here. If you take out a small cross section from this chamber, it is made of ceramic material of honeycomb structure with several flow passages. So the exhaust will be flowing through these small passages. And at the surface of this passage will contain small embedded particles of catalytic material. So we will be embedding this catalytic material along this passage and it will reduce the temperature required for oxidation. So we already see that the temperature required for oxidation of carbon monoxide is 700, hydrocarbon it is 600. Similarly, nitrous oxide have another temperature, but this catalyst will reduce that to very low temperature, that is 250 to 300 degrees Celsius. So already we know that the exhaust gas will be having some temperature near this. So we don't have to provide heating to this. Already the temperature of exhaust will be in this region. So that is the advantage of catalyst. We are increasing the reaction. We are reducing the temperature required. Now we are using aluminum oxide. The material used for as a base ceramic material will be aluminum oxide, which is known as alumina because of its low thermal expansion and it is chemically neutral. It will not take part in any reaction and it also have the high temperature withstanding capability. So we will be using the aluminum oxide or alumina as the ceramic material. And what are the catalysts used? Yes, they are rare metals, the platinum and palladium. The platinum and palladium will be used as a catalyst for promoting the oxidation of carbon monoxide and hydrocarbons. So already you know the reaction, just like the thermal converter, these are the reactions. Carbon monoxide will be oxidized to form carbon dioxide. hydrocarbons will be oxidized to form carbon dioxide and water vapor. So these reactions actually require a 600 degree or 700 degree temperature, but if it is used with this help of catalyst, we can reduce that temperature to 250 to 300. So which will be the normal temperature of a exhaust. So that is the advantage of this. And similarly, the rhodium, another rare metal, rhodium promotes the reaction of nitrous oxide and nitrogen dioxide. These are the reactions. So nitrogen monoxide will react with carbon monoxide from nitrogen and carbon dioxide. So nitrogen is safe because it is inert. It does not produce any harm to the environment. And this again another reaction, nitrogen monoxide will react to carbon monoxide to form N2O and CO2. And it will also react with the hydrogen to form similar reactions, nitrogen and water vapor. So these are again ammonia is formed with water vapor. So these are number of reactions happening. So all these reactions we can see that the nitrogen monoxide is converted to either nitrogen or N2O or ammonia. So both these are harmless gas compared to nitrogen monoxide. So these reactions will speed up using rhodium. And another one more catalyst is cerium oxide, which will promote water gas shift reaction. This is an important reaction in chemistry. What is water gas shift reaction is carbon monoxide will react with water to form carbon dioxide and hydrogen. So this reaction is used for production of hydrogen. Carbon monoxide and water vapor will react to form carbon dioxide. So carbon dioxide and hydrogen are safe. So this is another reaction takes place if we are used cerium oxide. So these set of reactions will convert the harmful gas to harmless gas. So that is happening here. With the help of this catalyst, these harmful gas are converted to harmless gas. And what is conversion efficiency? We have another conversion efficiency is how much of this gas, percentage of this gas will be converted to these products. So that depends on temperature. We can see here this conversion efficiency versus temperature graph for a catalytic converter. So you can see here if the temperature is 400 degrees here, the conversion efficiency of CO carbon monoxide is almost 98% at this point, 98%, and hydrocarbon it is 95, and nitrous oxide is this curve, it is also around 95. So that means if we are able to get a temperature of 400 degree, almost 98%, 95% these gas will be converted into harmless products. But if the temperature is reducing, you can see here there is a drastic drop. For example, at 250 degree, only 50% of hydrocarbon will be converted. And similarly, carbon monoxide also, it is very, very less at 200 degrees. So like that, if temperature is less, this will not work. So we have to maintain at least a 300 or 400 degree temperature in this chamber. Now what we are moving to particulate traps. So you already know that particular material or might soot carbon particles coming from mainly diesel engine. Petrol engine it will not be that much high. So particulate traps will be fitted in the exhaust pipe. So it's something similar to a wire mesh. So particulate traps are used in CA engine to reduce the amount of particulate released to the atmosphere. And they are like filter-like substance. You can see made of ceramic in the form of a monolith or mat. So it looks like a wire mesh of several mesh made together to filter this. And they can remove 60 to 90% of particulate in the exhaust. But what is the problem here? Yes, when we are using continuous, these particulates will be sticked into this wire mesh. So with the continuous use, they will fill up. They will fill up with so many carbon particles, and which will reduce the exhaust flow. So the exhaust has to be passed through this filter. So if we are using it for a long time, it will restrict the exhaust gas flow and raise the back pressure. So that will cause engine some problem. Its temperature will increase and fuel consumption will increase. So that is a limitation of this method. If you are use particulate trap for a long period of time, the carbon particles will get trapped here and it will accumulate and it will block the passage of exhaust and the pressure will increase, temperature of the engine will increase and fuel consumption also increase. So what to do to eliminate this? To avoid this, they will be combusting or we will burn these carbon particles after some use using the oxygen in the exhaust at around 550 to 650. So that we can burn these carbon particles at a frequent interval using oxygen and this temperature. And for this, some engine use automatic flames. So at the particulate trap, at the side of the particulate trap, we will have automatic flame or electric heater. So they will automatically act once the pressure drop is very, very high. So it already have a predetermined value. If that pressure drop due to this accumulation of carbon particles reaches that value, automatically this flame at the side will work and will burn these carbon particles. So that is the method used in most of the engine. It will have an automatic flame igniters which will combust this once the pressure drop reaches a predetermined value. And in some large trucks and stationary engines, the engine is used for power production, etc. This is not possible because a large number, it will take too much of time. So we have to remove this particulate trap and we have to regenerate it externally in a furnace. So we can remove this particulate trap and we can burn the carbon particle externally in a furnace and we can reuse it. So that is the method used for large engine and stationary engines. Now what is the method? Another method is we can reduce this emission by chemical treatment. For example, ammonia injection system. So it is used in some of the marine engines and stationary engine to reduce the NOx emission. What we will do is we will spray a small amount of ammonia to the exhaust and it will give this reaction. Ammonia will react with the nitrogen oxide and oxygen to form nitrogen and water. So we are converting into harmless products. And similarly, nitrogen dioxide also will react with ammonia to form nitrogen water. So both the nitrogen monoxide and dioxide we are converted into nitrogen and water vapor with the help of this ammonia injection. But it is not suitable for automobiles and smaller engine. We know that the storage of ammonia we require a tank and we are to use a complex injection and control system. So all these are not possible in automobiles and smaller engines. But we can use it in marine engines or large stationary engine. This method is used. Similarly, several research is going on for these chemical methods. For example, as cyanuric acid is a low-cost solid material. We are injecting it into the exhaust. It will sublime in the exhaust and produce isocyanate. And this isocyanate, a compound that will react NOx to form nitrogen and water. So again, we can use several chemicals, several research is going on, but these methods will not be that much appropriate for automobiles due to this size limitation and this complexity of the system. For example, another example is zeolite molecular sieves can be used to again NOx emission. So all these are chemical methods for converting this into harmless products, but these are limited to these large engines and special application only. Now finally we are going to have the exhaust gas recirculation known as EGR. So this is an in-cylinder method. So what all other four methods we have discussed is after treatment. That is, once the exhaust is produced, we are ejecting it and then only we are treating that to conversion of gas in thermal converters, in catalytic converter, in chemical methods, particulate traps. All these are after treatment method, but this EGR is a in-cylinder method. So we will be treating the gas inside the cylinder itself, not outside the cylinder. That is, it is known as a in-cylinder emission control method. Now what is EGR? Just look at this figure. You have any idea what is EGR is? Yes, we are the exhaust. You can see that we are taking a small part of exhaust and we are feeding it again to the cylinder. So some of you may think it as a weird, because why we are providing the exhaust again to the engine? We have some reason. So we know that this exhaust gas EGR method come from this point, that is the NOx emission. We can know that we can reduce it by reducing the combustion temperature. So NOx reaction of you know that the nitrogen and oxygen will react to form nitrogen oxides only when a temperature reaches beyond a certain value. So if we have somehow reduced the temperature by diluting the air fuel mixture with a non-reacting gas, any non-reacting gas we can use, which will absorb the energy during combustion, we can reduce the NOx emission. So what is the possible non-reacting gas available in the engine? No other gas we can use, because the storage will be a problem. For example, helium, we can use helium or argon, but all that will require increase the cost and storage. Then only the possible way of a non-reacting gas is we can use the exhaust itself. The exhaust will not be burned again, because it is already burned gas. So we can give a small percentage of exhaust. So the EGR means we are reverting back a small percentage of exhaust into the system, and that is immediately after the throttle. So here we have a throttle valve which will be connected to your acceleration pedal, and after that we will be providing this exhaust gas using a EGR valve. Now what is EGR? It is, we can represent as a percentage, it's a mass percentage of exhaust to the total intake. So that means EGR normally it is represented as percentage, 30%, 20%. It is a ratio of how much mass of exhaust we are giving to the total mass of content inside the cylinder. So EGR is mass of exhaust gas to the total mass inside the cylinder at a particular time. And how many exhaust gas will be present? The total fraction of exhaust gas during combustion stroke, X. What will be its value? It will be XR. XR means already some exhaust residuals will be there from previous cycle sticking into the cylinder walls, etc. So XR plus EGR by 100 into 1 minus XR. So this is an equation used for finding out the fraction of exhaust at a particular combustion stroke. So before producing power, how many fraction of exhaust gas will be there can be calculated using this simple relation. So the fraction will be equal to XR. XR is already what is the fraction of exhaust residuals from the previous cycle, plus EGR divided by 100, because it is in percentage, we are divided by 100 into 1 minus XR. And the amount of EGR, it will vary according to the load. When load change, this valve will have automatically control and it will open and close accordingly. So it will vary from 0 to 30%. And who will change this percentage? We will have a engine management system, a microcontroller and sensors will be there, which will sense the inlet and exhaust condition, and it will pass signals to the microcontroller, and it will be controlling the EGR valve position. So it is a variable. The EGR is not constant for a particular engine. It will vary according to different conditions, and it will be around 0 to 30%. Now what are the limitations? Already you have noticed this is not that much good method, because we are using already burned exhaust gas into the engine cylinder for reducing temperature. Now there is a question, what happens when temperature reduces? So it reduces NOx emission, of course, But what is the drawback of reduction in temperature? Any idea? Yes, you know that any engine, the efficiency will related to the maximum temperature of the cycle. So when the maximum temperature of the cycle reduce, its efficiency also reduce. You know that the Carnot efficiency is 1 minus T2 by T1. So as the temperature decrease, the thermal efficiency also reduce. That is the important drawback of EGR. So if you are using EGR, the NOx emission reduce, but on the same hand, the efficiency also reduce. And another thing is, this is very important limitation, the hydrocarbon emission will increase. So it's due to partial burning, the mixing of this exhaust with the fresh air fuel mixture will reduce the hydrocarbon or increase the hydrocarbon emission. And similarly, the solid carbon should also increase. So these are the three limitations of EGR: efficiency reduce, hydrocarbon emission increase, and solid carbon particle also increase. And there is a problem of very much increase in solid carbon particle, that is, this solid will break down the lubricant and it will cause wear and tear of piston rings. So it will act as abrasive particle. You know that in production you have already studied what is abrasion, abrasive particles. They are used for grinding. So these carbon particles will act as an abrasive and they will break down the lubricant and it will cause the wear and tear of piston rings. So this is not a good method. Provided you have to use that much control over EGR valve by microcontroller and other sensors, etc., then it is okay. But otherwise it is not desirable. So these are the overall view of EGR. So this 5 method you have to study in this catalytic converter is very, very important. So we have some beautiful animations. The link is given in the description box. So just watch that, the working of catalytic converter. Similarly, EGR, thermal conversion method, all these are important. So with this we are ending the air pollution and remedies part. And for further clarification, you can refer any of this textbook. Thank you.